Hello friends, last class I discussed about the different OPDs based on the wavelength. So based on the wavelength we can design different kinds of the OPDs. So this class I will discuss same thing but different application I will tell. Right, as we know there are the visible range, UV region in the wavelength and the infrared region in the wavelength, right? So based on the UV region, in visible region and infrared region, we can design different kinds of the OPDs, right? So here you could see, so this is suppose UV, visible, infrared, IR, right? So you can design broadband OPD, last class that I discussed, and the monochromatic OPD, panchromatic OPD, single length OPD, different kind of the OPD you can design, right? So first today one thing I want to discuss, that is the wavelength selective OPD, right? Wavelength selective OPD. Wavelength selective OPD means, so we can design a one OPD, right? Suppose multiple layers are there, right? This is OPD, multiple layers are there. So if multiple layers are there, then it can give the photo response from UV to IR region, suppose, right? But what is the wavelength selective OPD? What is the wavelength selective OPD? So we can design the OPD in such a way, so we can choose particular wavelength. Suppose if want to use such kind of the OPD in UV region, we can easily use, and if you want to use same OPD for the other red or blue region or orange region, we can also use, right? So there will be the absorbing layer. So multiple layers, suppose OS1, OS2, OS3. Multiple layers should be mixed with each other, right? So normally this, that means it can show the wide response, right? But if we apply different kind of the bias, right? If we apply different kind of the bias, kind of the bias, okay, so it can show different response. First if we apply the forward bias, it will show one kind of the response. If we apply the reverse bias, it will show different kind of the response. Otherwise we can also add. So already some polymer materials were used for designing such kind of the OPD. Multiple polymers, three different kind of the polymers were used for designing the wavelength selective OPD. And apart from that, one OPD was designed. In this OPD can show red region. Also, it can absorb the blue light. Okay, instead of showing the blue light, instead of detecting the blue light, it can absorb the blue light. Only it can detect the red light. So suppose one is the CUTC, C60 layer is there. So it can give, C60 has a wide absorption region in blue region, it has absorption region in the red region. Suppose, so if any extra additional layers are not there, suppose it is showing such kind of the response. Okay, it can detect the blue light as well as the red light. Okay, but if we add additional layer, okay, if we add additional layer, suppose P60, B3PT, such kind of the addition layer, if we add, so by adding this layer and with the help of the bias condition, it can absorb blue light. It can only detect the red light. If we add the P6 layer, if we increase the layer, it can absorb the P6 blue light. Only it can detect the red light. Okay. In this way, there is a role of the B3PT. These are the absorbing layer. By adding the absorbing layer, we can change the absorption range. Okay, that will be used for wavelength selective. As well as we have to apply the bias also. Okay, with addition of the absorbing layer, we have to apply the bias. Because the bias is bias, in another class I will discuss about this is also called the dual mode operation. Okay, so if we change the bias and the extra layer, that will be acted as a wavelength selective OPD, right? Next is the UV OPD. And before that, I want to tell why we can use the wavelength selective OPD. Wavelength selective OPD. Okay, this we can use for the artificial human eye, and apart from this, color image sensor. In this application, we can use the wavelength selective OPD. Okay, and next, biomedical imaging. Biomedical imaging is another important application. Biomedical imaging. These are the applications of wavelength selective OPD. Next is the UV OPD. UV. So by the name you can understand that the UV OPD, that is which can detect the UV light. Where we can use the UV OPD? Mainly missile application, missile warning application. Next, smoke and fire detector application, fire alarm detector. In this application, we can automobile combustion monitoring application. We can use the UV photodetector. So earlier, lots of OPD were designed based on lots of photodetector were designed based on the gallium arsenide in only silicon and only gallium arsenide. These are the material by using this we can successfully lots of photodetector were designed which can easily shows good response, good response, right? So there is one parameter UV to visible rejection ratio. UV to visible rejection ratio. By checking this parameter, we can understand that whether it can totally detecting UV light or not. But it should detect a maximum amount of the UV light and absorb other light, right? So by considering this parameter, we can understand the performance of the UV organic photodetector. So what I told, so lots of inorganic semiconductors were used for the UV photodetector, but so it can provide a good response, okay, good UV to visible rejection ratio. But there is a one parameter that is a challenging parameter is that is the cost parameter. Okay, by using the organic photodetector, research is still going on. By using the organic photodetector, we can design the cost effective visible blind or solar blind UV organic photodetector. Okay, by using the polymer and polymer OPD and small molecule. Okay, both can provide with this UV to visible rejection ratio 10 to the power 3. Okay, already this polymer OPD provides with this 10 to the power 3 UV to visible rejection ratio as well as the small molecule OPD. Small polymer OPD means if we use the P3ST PCBM, this can give the this can detect the UV or light, right? And for case of the small molecule, mainly MT, DA, TA. This is the one of the most popular material which has a high absorption peak in the UV region, MT, DA, TT. Okay, high absorption is in the UV region, and it can provide almost 80% efficiency at UV light. Okay, MT, DA, TA, right? So, and polymer, for the case of the polymer, PTHD, PCBM, other lots of polymers are there. But for which a small molecule, this MTDATT, this is the one of the most common material which is used for UV OPD design applications. Right? So now 80% efficiency we achieve. Researcher achieved 80% efficiency in the UV region. Okay, so for case of the for if want to design cost effective organic photodetector, so for this normally UV organic photodetector is required, and the researcher already published high performance UV organic photodetector. Next is the infrared IR OPD. So application of the IR OPD, that is the machine vision, computer vision, optical communication. Okay, computer vision, optical communication, environmental monitoring. Lots of applications are there. Okay, for IR photodetector, lots of applications are there. Computer vision, optical communication, and environmental monitoring. So if you think about the IR region, okay, if you think about the IR region, there are the three regions. Okay, one is the near infrared. Near infrared is 718. This is the near 780 nanometer to zero point 0.3 micrometer. Okay, mid infrared, mid IR. Mid IR is 0.3 micrometer to 50 micrometer. Far infrared, far IR, that is 50 micrometer to almost 1 millimeter. Okay, so already lots of papers are published based on the near infrared photodetector, and but mid infrared and far infrared, these are the mainly important for the optical communication applications. Okay, mid infrared and the far infrared, these are the mainly applicable for optical communication application. But so lots of inorganic photodetector and the hybrid, say graphene based photodetector already published for detecting the mid infrared and the far infrared. But in case of the organic photodetector, research is still going on, right? So going on already this region. If you think about this region, near infrared, so lots of photodetectors are there, organic photodetector. But few photodetectors are published for case of the mid infrared and the far infrared, right? So what kind of photodetector we can use? So PTT is the one kind of the PTT is a polymer. Okay, this is the one of the polymer which can be used for the near infrared photodetector, right? Already it can give the almost 80% EQ in near infrared region. And apart from the polymer, so lots of small molecules are available. So mainly the phthalocyanide. Okay, CuPC, ZnPC. Another is the lead phthalocyanide, lead tin phthalocyanide. Okay, these are widely used for the near infrared to mid infrared region. Okay, so maximum absorption, maximum photoresistance spectrum was observed up to 1800 nanometer with the efficiency of the 40% almost. Okay, so by using this lead phthalocyanide, zinc phthalocyanide, tin phthalocyanide, we can achieve the infrared photodetector response, and make till now up to 1800 nanometer response was achieved by the organic photodetector, near infrared organic photodetector. Right. So if we include other inorganic materials or graphene based materials with the organic material, we can easily achieve the this response. Okay, we can easily achieve the far infrared response. But so for case of so normally what kind of the criteria are required? Mainly cost effective criteria are required, right? So these are the whatever polymers and small molecules I have discussed. These are the normally commercially available. Already some chemistry researcher already designed this thing, and these materials are commercially available. Okay, within a within a low cost, right? But if we synthesis if we co-mix different kind of the organic materials, and if we synthesize such kind of the organic material for near infrared photodetector, this will be more suitable. but it will take time and it will cost more cost. Okay, more, it will be costly, right? So research is still going on. So if we co-mix different kind of the organic materials, and if we co-mix organic and inorganic material, we can easily achieve the far infrared and the mean infrared OPD. But as these are the time consuming and the costly, cost is the one of the factor. So normally researcher published a simple organic photodetector, and in which the materials, whatever materials were used, these are the commercially available. Okay, so chemistry people, they can synthesize the materials, right? And the electronics and the physician, they have to publish the design the device, right? So you need some materials which are the commercially available. Okay, that will be more time, less time consuming and cost effective, right? So if we think about this thing, so if we the chemistry, the synthesis of the new organic materials are still going on. Okay, so that's about the near infrared photodetector, UV photodetector, and the wavelength selective photodetector. So apart among all the photodetectors, organic photodetectors, mainly the near infrared photodetector is important. So this is the one of the drawback or challenging issue in case of the organic electronics. So already lots of inorganic and hybrid photodetectors are available, but organic photodetectors are not available till now in the market for case of the near infrared. So research is this is the one of the challenging issue. So thank you. Next class I will discuss about similar to this topic only. Thank you.